This is GCSE AQA Chemistry. It's a dual award and triple award topic, and this is part 5 of the bonding section. In this video, we're going to take a look at an introduction to covalent bonding. I'm going to recommend that you pause as you go, trying the activities for yourselves. So, within this video, we're going to look at how covalent bonds are formed, how we can represent them, and we are going to look at what type of substances contain covalent bonds. We've got a really important definition here. A covalent bond is a shared pair of electrons. And we can also see here it's explaining that it occurs between non-metals. So carbon dioxide, carbon and oxygen would be a covalent structure. Water is hydrogen and oxygen, two non-metals, so a covalent structure. Now, there's a huge amount of information on this slide that I'm going to recommend you pause and read through. I'm not going to go through all of that with you, but we are going to use some of this information so that we can start to build some of the dot cross structures for covalent bonds in a moment. And once you've read through this one, we're going to take a look at some examples, and we can see here hydrogen, two H's bonded together. Now, we are looking at one of the hydrogens. Hydrogen is in group 1 in a sense. It's got one electron in the outer shell, although it's not technically group 1, but it has one electron in its outer shell. So it needs to gain one to get a full outer shell, and to gain one, it will form one covalent bond. So the hydrogen puts its one electron into the shared area. And the other hydrogen does exactly the same. So my dot cross structure for an H2 molecule looks like we're seeing in figure 2. So now let's try this one. I'm going to go through and I'm going to use chlorine. It's not a central atom, but I'm going to say chlorine is in group 7. And if chlorine is in group 7, that means it has 7 electrons in its outer shell, which means it needs to gain 1 electron. If it needs to gain 1 electron, it will form one covalent bond. So it puts 1 in for sharing. Now, chlorine has 6 more electrons, so I'm going to put all of those around the non-shared section of the chlorine shell. And I've put the hydrogen one in as well. So hydrogen always wants to gain 1. We'll always put 1 in. It will always look like this if you have an H. But the hydrogen now has 2 electrons in its outer shell. It's full. And chlorine has 8 electrons in its outer shell, also full. So let's have a look at Cl2. Well, follow those same rules again. Chlorine is in group 7, and that means it has got 7 electrons in its outer shell. That means it needs to gain 1 electron, which means it will share 1 electron. And that means it will put 1 electron into the shared area to form a covalent bond. From there, it has 6 remaining, so I've put my other 6 around here. The other chlorine is doing exactly the same. 1 in for sharing, 6 unshared. Each chlorine has now got 2, 4, 6, 8 electrons. 2, 4, 6, 8 electrons. It's got a full outer shell in both cases. Taking a look at a slightly more complicated one now, we've got methane. Methane is CH4. I take my carbon, which goes in the centre. Carbon is in group 4, which means it has 4 electrons in its outer shell, which means it needs to gain 4. And that means it will form 4 covalent bonds. Now, within my ring structure, there are 4 different shared areas. So carbon puts 1 of its electrons into each of those. Each hydrogen puts 1 into its shared area. And I can see here that each hydrogen has now got 2 electrons, full outer shell, and the carbon has 2, 4, 6, 8 electrons in the outer shell, a full outer shell. So let's try ammonia. Ammonia, I'm going to draw out. I've got my nitrogen in the centre. Nitrogen is in group 5, which means it has 5 electrons in its outer shell. That means it needs to gain 3, and that means it will need to form 3 covalent bonds. There are 1, 2, 3 shared areas, so nitrogen puts 1 into each of those 3 shared areas. It has 2 left over, so they go non-shared up here. Now the hydrogens each have 1. Want to gain 1, will form 1 covalent bond. I put those in. Each hydrogen now has 2 electrons in its outer shell, and the nitrogen has 2, 4, 6, 8 in its outer shell. Now let's try oxygen, O2. So no central atom here, but I can see that I can pick any of the oxygens. Oxygen is in group 6. which means it has 6 electrons in its outer shell, which means it wants to gain 2. To do that, it's going to form 2 covalent bonds. Now, I've used 2 of its electrons, so that means I have 4 more to go on the remainder of the shell. If I do exactly the same with the other oxygen, I can now see that I've got 2, 4, 6, 8 electrons around this oxygen, 2, 4, 6, 8 around this oxygen, and they've both got a full outer shell. And if I show you a different way of representing this, I've got nitrogen with 3 single covalent bonds, which we represent as sticks. Because I've got 2 pairs of electrons in that one shared area between the 2 O's, I've actually made a double bond, which you might be familiar with from your work on alkenes, which essentially works in the same way. 2 more examples for you to try. So I draw on my water. Oxygen is in group 6, which means it has 6 electrons in its outer shell, which means it wants to gain 2, which means it will form 2 covalent bonds. There's one shared area, so it puts an electron in each one, and it's then got 4 left over. The hydrogens put 1 in each, because they're getting 1 back. Each hydrogen, now 2 electrons in the outer shell, and the oxygen, 2, 4, 6, 8. Everything has a full outer shell, so we've got what we needed. And we have then got nitrogen. Nitrogen is N2. Nitrogen is in group 5, which means it has 5 electrons in its outer shell, which means it needs to gain 3, and that means it will form 3 covalent bonds. But there's only one shared area. So the nitrogen puts 3 electrons in. It has 2 left over, so that's all 5 from the nitrogen on the left. But the other nitrogen will do exactly the same. The nitrogens now have 2, 4, 6, 8 electrons. 2, 4, 6, 8 electrons. They've both got a full outer shell. What we've actually created here with three pairs of electrons is a triple bond between the ends. That takes us to the end of this video. Thank you for listening and goodbye.